Let's start off today's lesson by talking about some things you already know how to do and are really, really good at. Can we do that? Can you tell me the answer to this? Now, is that hard? No, that's something we've done for a long time, right? Okay, what about this? Ooh, it's subtraction. Oh, still not hard? Okay, 8x squared. All right, good. What about this one? That's a 3. Sorry, I messed up. What is it? 12x squared, right? We multiply. What do we do when we multiply like bases? What do we do with the exponents? Add. You okay with that? Okay. What about, what do you think is going to be next? Prediction. You're dividing. Okay. What are we doing? Okay, so what do we get? 2x squared. Okay. Any questions? That's the preview of what we're doing today. But if you can do these really well, you really got today's without any problem. Okay? Because here's what's going to happen on today's. I'm going to give you some information like this. I'm going to tell you what a function we'll call f, and I'm going to tell you what a function called g is. I'm going to define both of those for you. And I'm also going to give you an x value. That'll come into play in a second. Okay, but this is what you're going to be given as the problem. Okay? First thing I'm going to ask you to do is add them. How could you tell that was adding them? Because of the plus sign? Okay, that's a good start. F plus g of x. Does that make sense? It's adding those two functions. Okay, so f is negative 3 cube root of x, and g is 12 cube root of x. What is negative 3 cube root of x plus 12 cube root of x? 9 cube root of x. Done. What's the domain of that function? What's it look like? Okay, yes. If you don't remember, what could you do? Graph it in your calculator. I'm going to add a page that's a graph. I'm going to put in 9 cube root of x. Can you see it? It's an S. It just kind of goes off. It might help if we zoom out a little bit. Change our window. Let's go ahead and zoom out from there. And I'll zoom out again. Does that look more familiar? Okay. What's our domain? All reals. Our domain is all real numbers. How else could how else could we write it? So negative infinity to positive infinity. So basically all the way to the left and all the way to the right. Are these two any different? This one is inequality notation, this one's interval notation. It's the only difference. Any questions about that so far? So what if I ask you to find f plus g of negative 8? What does it want us to do? So instead of writing an x, I'm going to write a negative 8. Do I have to do this math again? No, I already did it. So I already know that f plus g of x is 9 cube root of x. So can I start right there? So 9 cube root of negative 8, right? Now, somebody earlier said, oh, that's going to be an I thing, right? Because it's a negative under the root sign. Well, except this is a cube root. Can I think of something times itself that equals negative 8? Yes. Negative 2 times negative 2 times negative 2 is negative 8, isn't it? So this part is negative 2. What do I do with that? The negative 2 times 9. Yeah, absolutely. What is it? Done. Okay? Yeah, I just substitute the negative 8 in for x and see if I can figure it out from there. Now, here's the good news. Calculator will help us if we struggle with this a little bit. I can say 9 cube root of negative 8. Oh, look, it's negative 18. Oh, look, that's what we got right there. They are the same. Yes, you are correct. Okay? Any questions? So what about this? Can you do f minus g of x? Okay, so let's remember f is negative 3. F of x is negative 3 cube root of x minus g of x, which is 12 cube root of x. Any guesses? Negative 15? Oh, okay, cube root of x. What's the domain of that function? Are you sure? I don't even have to graph it? Well, if you know what this one looks like, don't you know what this one looks like? It's just reflected and has a multiplier of 15 instead of 9, so it's a little bit more stretched out, isn't it? Using transformation rules, don't we know that? Yes, please. I would like you to give both notations for domain. Nope, only domain. Unless you just want to do range. You just go right ahead, knock yourself out. I mean, not actually knock yourself out, because I think that would hurt. I'm not doubting that you couldn't knock yourself out, because I think you probably could, but what about this one? Can't I just use this again? Because I just did f of g of x, excuse me, f minus g of x, and I got an answer. Now we want f minus g of negative 8. So can I start here? Okay, so negative 15 cube root of negative 8. Now, I want you to be careful about something. Maybe I want to show you this on the next example. No, I can't. I'll show you on the next example. Can I remind you real quick? If you put this in the calculator, you're going to get the right answer without any doubt. Okay? Negative 15 times negative 8 to the 1/3 power. Is that the same or different? It's the same, isn't it? Because negative 8, the cube root of negative 8 is the same as negative 8 to the 1/3 power, right? Okay, so tell me what the answer of this is going to be. 30, right? Because negative 15 times negative 2 is going to be 30. We were working on some of the ones earlier, and we put in negative 15, you can't see that, sorry. Negative 15 times negative 8 raised to the 1/3 power. And we were getting weird things like negative 30. This time it gives me 30, so let me look at my work real quick for the other problems and let me see if I can figure it out real fast. No. Be careful with this. That's all I'm asking you to do, okay? Negative 15, negative 8 raised to the 1/3 power. You know how the calculator likes to do order of operations, okay? And so sometimes if you just multiply it by negative 8 as opposed to putting the negative 8 in parentheses, it might mess up. Depending probably what the root is, whether it's a cube root or a square root, if it's an even root or an odd root. So just be careful of that if you're going to use the calculator for some of these. Because some of these you're going to really, really want to use the calculator. Like there's one probably in your homework that you're probably going to have negative 27 raised to the 10/3 power. I don't want to do that in my head. I mean, I could if I had long enough, probably eventually, but that's why we're using the calculator for these, because we don't want to get caught up in the arithmetic. We want to be able to do the functions. Does that make sense? Okay, so Just as a word of caution, be careful if you're putting this in a calculator. Probably want to use parentheses around a negative when you're raising it to a power. Is that fair? Okay. What about this? What if I give you some new functions? What do you think I'm going to ask for next? Close. Multiplication. Okay? So we're going to say f of x is 3x squared times g of x, which is the square root of x, right? I don't like the way that this is set up. I think it's easier, in my opinion, my personal own opinion, to write it a different way because I think it makes more sense. The way that I want to write it is this. Because now I have like bases, and if I'm multiplying like bases, I just add the exponents, don't I? And I can do 2 plus 1/2 pretty easily. What is 2 plus 1/2? 2.5. Do we want mixed numbers in our exponents? No. So I really need to add these, and when I add them, I need common denominators, don't I? So this is really 2 and this is really 4, right? So it's 4/2 plus 1/2. 5/2. So that's what I want as my exponent, is 5/2. Okay? What's the domain of this function? What kind of root is it? It's an even root. So what does an even root look like? No. An even root looks like a square root, doesn't it? It's okay. It's right. It's a good guess. So just to make sure that we have a good idea of what we're doing, we're going to graph it in our calculator just to make sure we have a good visual. Okay? 3 times x raised to the 5/2 power. Oh. I drew it wrong, didn't I? Can you forgive me? Whoosh. Now, if it was just the 1/2 power, I drew it right? But it's a 5/2, so that changes what it looks like, doesn't it? Okay? But regardless, it starts here and goes to the right. So what's my domain? X is greater than or equal to 0. Or 0 to infinity. Okay with that? Can you tell me about f times g of 9? Where can I start? 3x to the 5/2, so I have 3 times x, which I'm going to put as 9 to the 5/2 power. Now this one we might be able to do in our head. Can you? What's the square root of 9? 3. What's 3 to the 5th power? Okay, I know 3 to the 4th power is 81. So if I want to get one more power, 81 times 3, 243. Okay, right? And then this right here is 243. So if I multiply that by 3, what do I get? $729. Now, could we do that in our calculator? Absolutely. Okay? But you know, sometimes I want you to think with your head. And not always use the calculator to do your thinking. Okay? There's a difference between pushing yourself and punishing yourself. Okay? Pushing ourselves is doing this with our head. Punishing ourselves is trying to do 27 to the 10/3. Okay? You see what I'm saying? Okay. What about this one? Well, f is 3x squared. G is the square root of x. Is that how I want to leave it written? No. Probably want to have 3x squared over x to the 1/2. I already know common denominator would be 2, and that's 4/2. You mind if I go ahead and write that? 4/2. Well, what do I do when I'm dividing like bases? Subtract. What's 4/2 minus 1/2? 3/2. Good. What does that look like if you graph it? It is. It is going to be x is greater than or equal to 0. The domain. Or 0 to infinity, right? Okay. What about f over g of 9? F divided by g of 9. I can start here. 3 times 9 to the 3/2 power. Excuse me. Square root of 9? 3 to the 3rd? Times 3? 81. Any questions? How do you feel about this? Good? Okay. This is function operations with rational functions. Okay. All of them weren't written as rational functions. This was written as a radical function. But to make our problem easier, we wrote it as a rational function, didn't we? Okay. Any questions?